Hi everybody, welcome to today's video for PROG1198. Today's topic is triggers. So let's get started. We're going to talk a bit about what is a trigger and different ways that we can use them, and then we're going to do some examples. So a trigger essentially is a specialized stored procedure, but the difference between a trigger and a regular procedure is that the trigger executes automatically in response to a database event. Either a DDL event, which is for data definition, or a DML event, which is for data modification. So DDL events are things like creating, altering, dropping objects, changing the structure of the database or the objects in it. DML events are events that actually affect the data inside the tables. So these are our insert, update, and delete events. And we can make triggers that will execute certain blocks of code automatically without our intervention whenever any of those events happen. So let's take a look at how to do this. Typically what we want to use something like this for is to capture auditing information, to maintain database integrity, or to control whether things are or are not allowed to change. So we can put a bit of restrictions on our tables or our objects. The most common use of the DDL trigger is to capture auditing information. So for example, if we wanted to keep track of when and by whom an object was created or altered or dropped, we could create a trigger that, for example, creates an entry in some kind of log or auditing table every time that action occurs. DML triggers are a little bit more common. They can be used for auditing information as well. Now we've looked at auditing once before, but this is a way to automate it so that we don't have to provide the data for the audit. It happens automatically without the user interacting. The other thing that we're going to use DML triggers for is to maintain different rules in our data. So for example, if we want to prevent certain updates or inserts, prevent certain records from being deleted, if we want to check for various error conditions, or if we have two or more different tables that we want to affect by one action, then we can create triggers for that. And one thing to note about triggers is that they're slightly different from procedures in that they can't accept input parameters or deliver any output parameters. Because they happen automatically behind the scenes, we can't directly interact with them. Now that doesn't mean that we can't access the data that we're trying to change through the triggers. So once we get into the examples, you'll see what I mean. So we can't execute triggers whenever we want. The only time that they get executed is when the event that they're attached to happens. So triggers are tending to slow down the performance of our database because they execute automatically. That means that if, for example, let's say you have a trigger on a delete action and you write a simple delete query, it will take longer than a regular delete query because the delete will happen and then the trigger code will happen as well. So we want to avoid using triggers to enforce referential integrity. We want to create foreign keys for that. That used to be more common, creating a trigger to say, for example, if you update the primary key, then cascade that update to all of the related tables. We know better ways of doing that now that don't involve a trigger. So you might see that in some legacy systems, but we're not going to code anything like that. So here's our syntax for creating a trigger. We start out with the word create, just like we do for all database objects. And then we have the word trigger, and we give our trigger a name. The prefix for triggers is TR underscore, followed by a name that gives some indication of what the trigger does. Now for a DDL trigger, we use the word on, and we can say on the entire server or on a particular database. So you can have a trigger that will run on any particular event, just on one database, or in all the databases on the server. Next is the for line. And on the for line, you specify a list of event types. So you want these trigger statements to run on what type of events. For example, if you're creating a table, do you want the trigger code to run then? Or if you are altering a rule. So there's lots of different things that you can do. Then you have as, and then the trigger statements. So it's similar to the way that we would create like a function. The header is a little bit more complex, but it has the same kind of idea. So the event type list, I put a link here to get a list of event types. Some of the more common ones are things like create, alter, or drop a table. Let's take a look in our SQL Server window. We can say to show us a list of all of the possible event types. We're going to go into our system schema and look for trigger event types. So we'll execute that, and it shows us a list. I listed the first three there, but you can see there's create, alter, and drop for index. There's all kinds of things for views and procedures and functions and so on and so forth. So you can provide code that would respond to any or all of these different events. Inside the trigger statements, you can write pretty much any TSQL or SQL command that you want. Typically what we would do there would be to insert values in a table that records the auditing information. So let's just do a quick little example. I'm not going to execute it because I don't have the table for that set up. We're not really going to focus on DDL triggers, but I do want to give a quick example of how that would look. So let's create a trigger. We'll say tr table create. And we have on either all server or on database. So if we say on all server, then it will go for all the databases on this particular server. So we can have that, or we can have it on a particular database, like for example on username company. And after that we have as and our trigger statements. Notice I'm going to indent here because the trigger statements are part of this. Oh, my bad, I forgot the for. So we need to specify what types of events we're going to respond to. Now, I've called it table create because I'm going to respond to a table create statement. So if we take a look at the possible events, you can see create table is the first one. We can put create table right in there like that. So now we would want to write the statements. What's going to happen when we create a new table in username company? Now, typically what we would do would be to record some auditing information. So maybe we can say insert into, I don't know, what can we call our log table? TBL log. And we'll say current date. Now all these red lines are just because of batching, so we'll do a go there and that will solve it. Now in this case what we have is whenever we create a new table on username company, we're going to insert a new row into a table called TBL log. Now I'm getting some error messages here because I don't have a table called TBL log, but you hopefully get the idea of what we would want to do. Anytime you create a brand new table, we would get a new record with that username and the current date. So we would have this auditing records of actions taken against this table. And if we wanted to keep track of more of these, for example, we could say also do the same thing anytime a table is altered. So if you want to use more than one action, then you can put a comma between them. So here's an example of a DDL trigger. Now, if you wanted to try this out, all you'd have to do is create the table. Actually, why don't we give that a try? Before I create the trigger, I'm going to create the table. so that we have somewhere to put these log files. So we're going to write a quick little create statement here. Current user is a function that returns a name. So I'm going to store that in a varchar. Let's say, I don't know, 40. Maybe we'll even make a primary key too. Might as well make it a good table. There we go. So I'll make this table. Oops. So here's our empty table right now. I can practice an insert statement. Just make sure that works appropriately. Okay, so now that this thing exists, let's turn our attention back to the trigger. When I create the trigger, it's going to say that we're going to create a trigger for this particular database. Whenever we create or alter a table in this database, this action is going to happen. Let's put the word database here instead of the name of the database. Let's see, there we go. Now we're all good. Just got to clean up my syntax errors a bit here. It's not current user, it is system user. And we should be good now. Okay, so let's create the trigger. Now notice when I create the trigger, nothing actually happens yet. The trigger only runs when we create a table on this database. Okay, so nothing happened except for we've created the trigger. So now this database, username company, it's the current database, has this trigger on it that whenever I create a table or alter a table, we're also going to execute this insert statement. Okay, so let's test it out by altering a table. I'm going to write an alter statement on one of the tables in username company. So let's alter our customer table. I'm going to alter the customer table to add a new field. So let's add customer nickname. So when I perform the alter statement, I've got an error here. Oh, I don't have customer, I have employee. So we'll say employee nickname. So I've altered the table. The employee table should have that new column now. You can see how I've got the new column. But I also should have that extra record in our TBL log. Oops. So you can see there's record number 2, where I've got the username and the current date because of the trigger. So that demonstrates how the trigger works automatically in the background. It's just hanging out there. It doesn't do anything until you create or alter a table, but when you do, it also performs this action. So there's an example of a DDL trigger. Now, if you want to change a trigger, there's alter syntax. It's very similar. The only difference is you have alter instead of create at the start. If you try to alter a trigger that doesn't exist, you'll just get an error message. So if you need to change a trigger, all you need to do is change your create statement and change it over to an alter statement instead. Now, if you want to drop a trigger, syntax is very similar. Start out with the word drop, then trigger, and then the name of it. You can drop it across the entire server, or you can just drop it on this particular database. Now, another thing you can do with triggers is turn them on or off. So rather than just dropping it if you want to disable it, you can keep it there, but just disable it temporarily. So by default, when you create a trigger, it becomes enabled. But if you want to turn off the trigger, let's say, for example, our trigger that created a record in the logs. Well, if you're the database administrator, you might want to make some changes without them going into the log file. You can disable the trigger first, make your changes, and then enable it again. So there's syntax here to enable or disable an existing trigger. Okay, let's move on to DML triggers. These are triggers that work in response to insert, update, and delete events. So DML triggers are a little bit more straightforward because there's only 3 possible event types. However, they're a little bit more robust for what we want to use them for, because now we can control when they happen. So if you look at the syntax for a DML trigger, it's similar. We start out with create trigger and the name. We have the word on, but what it is on is slightly different. So you can create a trigger on an individual table or on an individual view. Now remember that the trigger is going to respond to insert or update and delete. So that means you can create a trigger that will respond to an insert on a particular table or a particular view. And next we see after or instead of. The event type list can be insert or update or delete, or a combination of those 3. So the trigger name has to be unique, should follow the rules. TR underscore is the prefix. The on clause is the name of the table or view. The event type can be insert, update, and or delete. And then for the options, we had either after or instead of. So the after option means that your original action query, your insert, update, or delete that you write, will execute first, and then the trigger code will execute after. Your other choice is you can write an instead of, so that if you write an insert or update or delete and it has a trigger that says instead of, your original query won't run, and your trigger code will run in its place. So after means that you're going to run both. Instead of means that you run the trigger and not the original query. You'll also see in some legacy systems a for option. It's supported for backwards compatibility, but it means after. So we're going to use after instead. So we don't put in for, you put either after or instead of. Okay, now before we take a look at inserted and deleted tables, let's take a look at some basic DML trigger syntax. So if we want to create a trigger on a particular table, let's say, for example, on the employee table, I'm going to start off with create trigger and a name. And we're going to write a trigger that responds whenever we insert a record into the employee table. So I'm going to call my trigger employee insert. We specify which table. And then we specify what we want to happen. We want to say either after insert, which means that the insert query will run and then the trigger will run. Or we could say instead of insert, which means that only the trigger will run and the insert will actually be ignored. So we'll try it with after first, and then we'll take a look at the instead of one. Okay, so our trigger code here, let's keep it really simple and just print a message. Insert successful. So what's going to happen if I execute this create statement? We create that trigger in the database. Now the trigger is just waiting for us to perform an insert on the employee table. So that's when it runs, when you insert something into employee. So let's give that a try. I'm going to insert into employee. What fields do we require here? Let's take a look at the columns. So we need a first and a last name, and the rest of them are optional. Oops. Okay, so here's an insert into employee. When I execute this, the insert statement is going to run first, and then after the insert, this statement is going to run. So I'm going to execute our insert. So we saw that message come up, as well as the one row affected come up. Just to prove that the insert did actually work, we can check out our employee table and see the new record down here. So whenever the insert happens, it finishes first, and then this happens after. Okay, now let's change it to an instead of. So I'm going to alter the trigger, and we'll say instead of. So instead of insert, I'm going to print a message saying insert not successful. Why was it not successful? Well, because this print statement is happening instead of the actual insert statement. So let's alter our trigger. And we'll try again to insert a new employee. So when I execute this insert statement, you can see our insert not successful message. So the trigger ran, and the trigger should run instead of insert, which means that the insert statement does not actually successfully execute. Now we're seeing one row affected, so you might be thinking, okay, well, it looks like it was inserted, but if we go into our table, you'll see that it's not there. Well, why do we see one row affected? It's because of a transaction. So the way that triggers work is that your original statement that causes it starts a transaction, and then the trigger code continues that transaction. Now, if you have an instead of, what happens is the original transaction is rolled back before this happens. If you have a trigger that happens after insert, then the insert statement and the trigger code happen together in one transaction. And that's actually really nice and helpful for us, because whenever we know we're in a transaction, we have the opportunity, if we want to roll it back, which means that even if we get in here after an insert, we can perform a check, or we can perform some kind of condition to see whether we actually want to allow this insert to happen or not. And we have the option, we could write like an if statement and say rollback transaction if something. Now, the common somethings that we look for of why we might want to, for example, roll back and insert. Sometimes we want to allow inserts and sometimes we don't. Maybe it'll depend on what data we're trying to insert. Let's say, for example, our employee salary value, we want to cap that at 100,000. And we want to say, if the salary that you're trying to insert is greater than 100,000, we want to reject that insert and roll it back. Or maybe we don't want to allow someone to be inserted with the title of CEO. Then we can check to say if the employee title is CEO, roll back the transaction. So we have the ability to check on the actual data that's being inserted. And that's what this slide is about. The inserted and deleted keywords. So these are temporary system tables that contain copies of the values that the command inserted or deleted or updated. The column names are the same as the column names in the original table. So we can use these to reference the values that are executing the trigger. Let's take a look at this. Now, when we're performing an insert, we have access to a special table called inserted. We only have access to it inside the trigger, but what I'm going to do is I'm going to alter the trigger again, and right now it says after insert. I'm going to select all from inserted. So in an insert trigger, you have this table called inserted, and it references all of the data that you're trying to insert. So let's alter our trigger so we can see what's in there. When I insert into the employee, oh, I should change this as well. When I insert into the employee, we will be able to select all from the temporary inserted table that contains all the new values. So here's the record of the new values temporarily from inserted. So we see that here because of the select output. We also see the insert successful message from the insert, and we'll see one row affected from the select as well. So everything that has happened is visible down here. So we can see that when we're inserting some new records, let's try it one more time with some different data. Let's say the employee title and employee start. So I'll provide some more data so that we can see more things in the inserted. Okay, so let's perform our insert statement. This is what we're seeing in the inserted temporary table. So now that I can find out what's inside of inserted, I can select from there, and then I can find out what values are in here. So let's say, for example, we wanted to avoid inserting employees whose salaries are over 100,000. What I'm going to do is I'm going to declare a variable to hold the salary. And when I select from inserted, I'm going to select and store it in that variable. So I'm going to get whatever's in the emp salary, and I'm going to put it into here. From there, I'm going to say if the new salary is greater than 100,000, I'm going to do two things. I'm going to print a message saying insert failed. Ideally, maybe we would want to throw an error here and give a little bit more information as to why it failed. But for now, we'll just use print, and we're going to roll back the transaction. That will stop the data from getting inserted. And if we get past that, then we'll just get down here. We could put this in an else, but we don't need to. Actually, I think I will put it in an else. Here we go, just to be consistent. All right, so let's alter the trigger. Execute this. Now let's try again to insert an employee. This time I have to provide a salary. And I'm going to provide a salary that is greater than 100,000 so we can see it fail. So let's say Jim, and as a title we'll say CEO. The start date is today, and the salary, we'll make it really high, so 200,000. Let's execute the insert statement. So we can see here that the if statement evaluated as true. So we rolled back the transaction and we print the insert failed. So you can see how rolling back the transaction produces this message. And if we go and take a look at what's in employee, we will not see Jim there. So you see that the insert got canceled by the rollback. Now if I try it again, let's put in a different name just to make sure. But I make this smaller. then the insert will happen successfully. So it was the if statement that caused it to fail. And we can see that the trigger allows us to introduce new referential integrity and database table integrity rules. Now we could do this with a check constraint as well, right? So there's lots of different ways to accomplish the same outcomes. So if you're in a trigger that responds to an insert action, then you can use that inserted table to get to the new data. If you're in a delete trigger, then you can get to a similar table, but instead of called inserted, it's called deleted instead. And that represents the data that's about to be removed from your table. If you're in an update trigger, you have access to both. So the nice thing about an update trigger is you can look in inserted to see new data coming in, and you can look at deleted to see the old data that's being overwritten. So that way you can use it to compare values between previous data and new data that you're updating. In an update trigger, you have access to both of those tables. So let's look at some more examples. This example creates a trigger on an employee table that prevents users from deleting more than one employee at a time. So what we're going to do is run the delete query. We're going to see how many rows were affected, and if it affected more than one row, then we're going to roll it back. So we want to create a situation where you can run a delete query on employees, but you can only delete one employee at a time. So let's code this up. We're going to create a trigger on employees. Create trigger tr employee delete. And we do want to allow the delete to happen. We don't want to replace it, so we're going to say after delete. Okay, so our goal is we want to find out how many rows were affected by that delete statement. Now, we know that we can get the deleted data from the deleted system table. So if I could get all of the data that's being deleted, then if I wanted to get a count of how many rows are being deleted, it's actually pretty simple to do. All we need to do is perform a count operation here. So we could assign this to a variable and then do an if statement on the variable, but I'm going to do a shortcut here and say if the result of this query is greater than 1. Let's say begin and end, because we want to do two things. We want to give an error message, and we want to cancel any deletes. So I'm going to raise an error. And we are also going to roll back the transaction. Notice I don't specify the name of the transaction. Because the transaction is created automatically by the system, I don't have the specific name. Okay, let's create this trigger whenever we delete from employee. So if I try to, first let's take a look at what we've got in the employee table. We've got employee IDs all the way up to 13. Notice that we don't have a 12. The reason we don't have a 12 is because the insert got rolled back. So it created the employee ID and then it rolled it back. It still incremented it though. Now, if I try to delete more than one employee, something like this, if I say delete from employee where emp ID is greater than 10. So that would delete both of these two records. Employee ID is greater than 10. So it's going to delete two records. However, when we count the number of records in that deleted system table, that value is going to be 2. 2 is greater than 1, so we're going to get rolled back. Let's try it and prove that that works. So you can see our error message happening there, and also the error message from leaving the trigger. Now, if I do a delete statement that only deletes one employee, let's say where employee ID is equal to 13, the delete works no problem. So it only stops you if you try to delete more than one record. And that is a very common trigger to create in order to control and prevent batch deleting. You know, typically you want to make sure that you're not deleting a whole bunch of stuff out of your table at once. It's just a safety protocol. Typically you might do that with updates as well to make sure that you don't accidentally update every record. So the code for that is in here in these slides. Now in this example, the trigger gets altered to only allow up to 6 records deleting. That's kind of a far-fetched idea. I can't imagine why you would want to restrict it like that, but just to prove the point of how you can alter it, altering the trigger to change that value to 6. Okay, now we're going to take a look at update triggers. In an update trigger, sometimes we only want to take action if a certain column is updated. So in this example, what it does is it checks to see if the employee last field has been changed. And there's 2 different ways to do it. This way uses kind of a shortcut, the update function. Now the update function is different than an update SQL statement. You know, you're not updating a record that already happened. This is happening after that. This update function with the brackets takes the column name as a parameter, and it will return true if that column has been updated. The way that it does that is it looks in deleted at the employee last name, and it looks in inserted at the employee last name, and compares them to see if they're the same. Now we can do that manually, or we can do it with this update function. So it'll be true if they're different, because that means that that field was updated. And it'll be false if they're the same. Now what happens here is if the last name has changed because of the update statement, then it will raise an error and roll back the transaction. If the last name hasn't changed, then nothing else will happen. So let's put this into our SQL code. Okay, I've pasted it into here. So we have employee update, and the name of the table is employee. I'm just changing the capitalization to be consistent between this and the other triggers. So after update, I'm going to start out by just commenting this stuff out. Because I want to show you what we get in inserted and in deleted when we try to update a record. So I'm going to select all from inserted and select all from deleted. So that's all our trigger is going to do right now, is just show the new data and the old data from an update. So let's create the trigger. And now in order to force the trigger code to execute, I'm going to write an update statement. So I'm going to update the employee table, and we're going to set the employee last name to Joshua, where employee ID equals 1. Now, before we do that, let's look at what's in employee table. Employee ID 1 is Marissa Green. We're changing her last name to Joshua. Let's perform that update. So the update is going to happen, and then after it happens, we're also going to see results from inserted and deleted system tables. So the first one is inserted. This is the new data. And the second one is deleted. This is the old data. You can see that the last name contains a different value. So deleted contains the old record, inserted contains the new record. One of the fields has changed. The rest of them, you'll notice that they haven't changed because my set statement only affected that one column. Okay, so now hopefully you get a better idea of how this update works. It looks at the emp last in inserted and deleted and compares to see if those values are the same. If they're not, update says true, and if they are the same, it means that they have not been updated, so it would return false. So let's take that away, and we'll recreate the trigger. I need to alter it so that it now prevents updates to the last name field. So let's put a new last name in for that employee. So I'll execute this. You see we get the error message, cannot change last name. So this evaluated to true, and we ended up in here. The return statement is optional here. You can break out of a trigger early by using a return. In this case, we don't need it because that's the end of the code anyway. Okay, so this update failed. We can take a look at what is in employee just to prove that it failed. You can see she's still got Joshua as the last name. Now, what about changing the first? Changing the first name will succeed because only if the last name has been updated will this line of code roll the transaction back. So you can see that the first name is changeable, but the last name causes this code. Okay, now how would we do this the long way? What we could do would be to declare two variables. I'm going to say old name and new name. Then I'm going to retrieve the old name. Oh, sorry, old name is coming from deleted. And the new name is coming from inserted. So I'm retrieving those two values, the updated name from inserted and the previous value. And they might be the same. If the update statement didn't change it, then they might be the same. And then my if statement here, instead of saying that, we'll say this instead. If the old name is not equal to the new name. So we can use this symbol, or we can also use the not equal symbol like that, either one. Or you can say not like. There's lots of different ways to compare for equality. That's what this is doing. You can see how this way is a bit longer. But now that we can access the old and the new data, we can pretty much generate any rules we want. You know, we can check to make sure that a person's first and last name aren't the same, or we can check to make sure that you know, a person's salary doesn't get lower than it used to be. You know, we don't want to give anyone a demotion. So there's lots of different choices and things that you can do by retrieving data from the deleted and inserted system tables. Now, just a bit of housekeeping here. You can alter triggers on a table through an alter table statement. So we can enable or disable triggers on a particular table, and you can choose to enable or disable all of them, or you can list them by name. We can drop a trigger by saying drop trigger and put its name on there. And the last piece of information that I'll give in this video is about finding out what kind of triggers you have in your database. So here are 3 procedures that you can execute to find out some information about your triggers. The first one, SP depends. You execute this and you put the name of the table, and it will give you a list of tables with triggers. Let's give it a shot. So we'll go down here, and we're going to execute sp_depends, and we put in the name of the table. So exec or execute, either one, the short form exec or the long form execute, the name of the procedure, and then the name of the table. Might need quotes around that. Nope, it accepted it. So when you execute this, you tell it the table and it tells you all of the triggers that are associated with it. Now, if you want more specific information, we can execute sp help trigger on this table, and it gives us a more detailed bit of information about the triggers. So sp depends isn't just about triggers. It's about all of the database objects that depend on this table. So if you have other things like views or procedures or functions or anything else that depends on this table, would be listed by that. The second one, help trigger, is trigger specific, but you can see that it gives you information about the trigger, whether it's coded for update or delete or insert, whether it's coded for after or instead of. And the last one here, sp help text, can be used with a database object, any object, but we're going to look at it with a trigger here. So I'm going to put in the trigger name, tr employee insert, and it will give us the text that was used to generate that trigger. So you can see that it shows all of the code, including the comments and everything that I used to generate that trigger. So this is actually very helpful if you come into an existing system and you want to check to make sure that the table doesn't have triggers, or if it does, find out how they work. Now another way that you can do it is through the Object Explorer. If you expand the table, you can expand the triggers folder, and you can see the 3 trigger objects listed there. You can right click and script it to a new query editor window. That will create a script that creates the trigger. But you'll notice that it regenerates a new script to create that trigger. So if we look at the example here, the text on employee insert is going to be slightly different than the create statement that is generated. You can see that there's a lot more going on around here. Okay, so that is the end of our lesson about triggers. I very strongly suggest that you try this week's exercise, because triggers can be a little bit tricky, and an additional extra practice is going to be really good for your understanding of these. And if you have any questions about triggers or any other course topic, don't hesitate to send me an email anytime. Until next time, have a great day.